Hi everyone. In today's class, we are going to see Z transform. In Z transform, one of the topic is inverse Z transform. In inverse Z transform, the very important topic is partial fraction method. Now we are going to see the partial fraction method. This is very important one. So in this method, I am going to explain one problem, that is determine Z inverse of Z divided by Z plus 1, Z minus 2 the whole square using partial fraction method. So first I am going to take that the given function is let Z divided by Z plus 1, Z minus 2 the whole square. This is maybe splitted into three constant. First one is a divided by z plus 1 and b divided by z minus 1 and c divided by z minus 1 the whole square, because here three terms is appear. First one is z plus 1, next one is z minus 1 the whole square. So we are going to use three constants, that is a, b and then c. Next we are going to take common factor, that is z minus 1 into z minus 1 the whole square. In the numerator, here z plus 1 appear. The remaining term is z minus 1 the whole square. So I am going to multiply here a into z minus 1 the whole square plus b. See the b denominator, z minus 1 only here. So I am going to multiply z plus 1. Next in C, z minus 1 the whole square, the remaining term is z plus 1. So I am going to multiply here is z plus 1. So I am going to cross the denominator. Both the denominators are same. So I am going to cancelling the denominators. Next the left hand side is we are getting only z, and the right hand side is a into z minus 1 the whole square plus b into z minus 1 plus c into z plus 1 plus c into z plus 1. Next, this is taken as equation number 2. Next, we are going to find the constant, that is A, B and then C. How we can find the constant? First, I am going to substitute the value Z equal to 1. Why we are substituting the value Z equal to 1? Because in question, Z square divided by Z minus 1 and Z plus 1. Okay. So, Z minus 1 equal to 0. So, Z equal to 1 is one of the value, and z plus 1 equal to 0 and z equal to minus 1 is another value. So I am going to first substitute z equal to 1. So in equation 2, what we are getting, left hand side is z, so 1 and a into 1. 1 minus 1 becomes 0. Here also 0. Here c into 1 plus 1. So 2c. So solving this, c 2c equal to 1, c equal to 1 by 2. Next, the another value for z is minus 1. So in a same manner, substitute in equation 2, we are getting left hand side is z minus 1 and right hand side is a into minus 1 the whole square plus b 0 and c into 0. So you are getting minus 1 equal to 4a. From this a equal to minus 4. Next we are going to find the constant c. Here next we are going to find the constant value, that is c. Here no value for to substitute. So I am going to equating the highest coefficient. What is the highest coefficient here? Z. First you are going to equate the highest coefficient z square. Next z. Next constant. I am going to equate the highest coefficient z square. You have to multiply inside the equation all the terms. So left hand side is no z square term. So I am putting 0. Here one z square term is a z square. So coefficient is a. Here a. Next b z square. So coefficient is b. So I am writing b. No other terms in the coefficient of z square. So these are the terms 0 equal to a plus b. And already we find out the value for a is minus 1 by 4 and then b. From this b equal to plus 1 by 4. Next I am going to substitute all the values a, b and then c in equation 1. That is the first equation. The starting problem is z divided by z divided by z plus 1 z minus 1 the whole square, which is equal to a value is 1 by minus 1 by 4 divided by z plus 1 and b value is 1 by 4 divided by z minus 1 and C value is 1 by 2 divided by Z minus 1 the whole square. These are all the values for A, B and then C. Once again we'll check. A is minus 1 by 4 and then C is 1 by 2 and then B is minus plus 1 by 4. Okay. Next, we are going to apply the Z inverse on both sides. Z inverse on both sides. Apply inverse Z transform on both sides. Apply inverse Z transform on both sides. We are getting Z inverse of Z divided by, that is the question, Z plus 1, Z minus 1 the whole square. For next, Z inverse of minus 1 by 4 divided by Z plus 1 plus Z inverse of 1 by 4 divided by Z minus 1 plus Z inverse of 1 by 2 divided by Z minus 1 the whole square. Taking the constant outside, 1 by 4 into is the inverse of 1 divided by Z plus 1. Same here also, taking the constant outside, 1 divided by Z minus 1. Here, taking the constant outside, 1 by 2, Z inverse of 1 divided by Z minus 1 the whole square. Next, using the Z inverse formula, we are getting Z inverse of 1 by Z plus 1, which is equal to A power minus A power n. We know the formula Z inverse of Z divided by Z plus 1 equal to minus A power n, and another one formula is Z inverse of Z divided by Z minus A, which is equal to A power n. We are going to use this formula here also. Now we are multiplying inside that Z. In the question you are having Z. So Z divided by Z plus 1 plus 1 by 4 into Z inverse of numerator value is Z. So I am going to multiply Z here. 1 by 2 Z inverse of Z divided by Z minus 1 the whole square. So we are substituting this formula. Finally we are getting the answer is, which is equal to minus 1 by 4 into Z inverse of Z by Z plus 1 minus A power n. A is 1 plus 1 by 4 into, here A is 1, so plus A power n plus 1 by 2 into Z inverse of Z by Z minus 1, the value formula is n. So this is the final answer. So we are getting the final answer is Z inverse of the question, that is Z divided by Z plus 1 Z minus 1 the whole square, which is equal to 1 by 4 into minus 1 power n plus 1 by 4 into 1 power n plus 1 by 2 into 1. Thank you.